Okay, so this will kind of wrap up our discussion of arithmetic series in terms of how to add them. So there's another way, besides the way that we talked about before, there's another way to write, or another way to indicate that we want to find the sum, and that's using something called sigma notation. So I'll give you, before we try any of these, I'll give you a real simple example and explain what this means. So first of all, sigma is this right here. Sigma is a Greek letter, and it means it's like the capital, that's a capital sigma. It's kind of like the letter S. And in this case, it's just Greek for sum. Okay, Greek for sum. So here's what that means. That means suppose that we had suppose it said find the sum of the terms from n equals 1 to n equals 4 of this right here. Here's how you would read that. Okay, this right here is the first number that you plug in to the formula to get your first term. Okay, so that right there is the first number that you plug in to get your first term. And then you go up until you get to this number. That right there is the last number that you end up plugging in to the formula to get, in this case, to get your fourth term. Okay, because in this example, the fourth term will be the last term. So let's just practice for now. Let's just practice writing out what this means. Okay, so if I plug in n equals 1 right here, I would get 5. Sigma means sum, so sigma means we're supposed to be adding these together. Now if I plug in 2 to this right here, I would get 10. If I plug in, the next thing of course would be 3, so if I plug in 3, I would get 15. And then finally, I'm going to plug in 4. How do I know to stop at 4? Because that right there is the last number I'm supposed to plug in. So if I plug in 4, I get this. So this right here, this whole thing right here, that whole sigma notation is another way of saying 5 plus 10 plus 15 plus 20. That's just another way of saying that. Okay, now that we know that, let's actually find the sums. And it might be helpful if we're doing this, we're going to use the same two formulas as before. It might be helpful to just expand this out so we can see what it looks like. So again, this is the first number that we're plugging in. That's the last number that we're going to plug in. So and they're using K right here. It doesn't really matter what letter you use. N is typical. I think N might stand in this case for number, but K sometimes is used instead to stand for constant. Let's just write out the first couple terms, and then we'll skip a few and we'll go out to the 13th term. So if I plug in 1 right here for K, I'd have 8 times 1 is 8, minus 18 is negative 10. If I plug in 2, I'd have 8 times 2, which is 16, minus 18 is negative 2. And then we keep going in that form all the way out to 13. If I plug in 13, I would get 8 times 13 is 104. 104 minus 18 is 86. And actually, let me just I'm going to do a third term in here just so we can see one more thing. So let's also get K equals 3, because then you'll be able to see, I think, a pattern here. So if I plug in 3 right there, 8 times 3, 24 minus 18 is 6. Okay, so now the question is, we have our series. All we did was take sigma notation and kind of expand it out. And now the question is, now we're back to figuring out which formula to use. So should we use the first or the second? Well, we know the number of terms. The number of terms here is 13. From 1 to 13, by the way, you might say, isn't it 12? Because 13 minus 1 is 12. Remember, we have to include the first term. So there's going to be 13 terms right here. So n is 13. There's going to be a first term of negative 10. We have that. And a last term of 86. We have that too. We also could have used this one by using the common difference. You might notice the common difference from negative 10 and negative 2 is 8. From negative 2 to 6 is 8. Now the question is, where does the 8 come from? The 8 is right there. That 8 is where the common difference comes from. So you look at number 8 right here, you can probably already tell. Think about it for a sec. What's the common difference going to be here? And if you guessed 5, you're exactly right, because that's a 5. So now let's just use the first formula. So we want the sum of the first 13 terms. N is 13 over 2. The first term is negative 10. The last term is 86. When we simplify this, we're going to get 13 over 2 times, that's going to be 76. That becomes a 1. That becomes a 38. And 38 times 19 is 494. And that's the sum of that series right there. See if you can pause the video and try number 8 on your own. And then if you want to go even further, try and see if you can also do number 9. I'm just going to move these down so we have these available. All right, so number 8, same thing. Let's practice using the second formula this time. We can use either one. We know that D is this number. D is 5. But if you want to really be able to see that, let's just expand this out like we did before. So we'll get the first couple terms here, and then we know that we're going to stop at the ninth term. So we'll stop at n equals 9. So n equals 1. Let's plug in 1 right here. 5 times 1 is 5, minus 15, negative 10. Plug in 2, we'd have 5 times 2, 10 minus 15 is negative 5. Plug in 3 for n, 5 times 3, 15 minus 15 is 0. And then finally plug in 9. 5 times 9, 45 minus 15 is 30. We skipped all the terms in the middle, but that's okay. So we want to find the sum of the first 9 terms. And we know we have 9 terms, so we're going from n equals 1 to n equals 9. So it's going to be, we're using this formula right here. 9 over 2 times 2 times a sub 1 would be 2 times negative 10, which is negative 20. And then plus common difference here is 5, because we're going up by 5 each time. N minus 1 would be 9 minus 1. So 5 times 9 minus 1 is 8. 5 times 8 is 40. So we have 9 over 2 times, this turns out to be 20. Those will cancel, and we're left with the final answer of 90 as the sum of that series. How would you do number 9 right here, which says find the number of terms? So notice they're not telling us what n is. All we need to do is pick one of these formulas and plug in what we need. So we don't know the last term, and we can't find the last term, at least not easily, because they don't tell us what n is. We could plug in n if we knew it to that formula, but we don't know it. So what can we use here? Well, it would probably be better to use this formula. So let's just kind of fill in what we know. So we know they're telling us that the final sum of this is 4830. Okay. We do not know n, so we're still trying to find that. We do know the first term, though, or we can find the first term. If we plug in n equals 1 right there, we'd have 8 minus 6, and that equals 2. And then let's just get a couple other terms we can see. Plug in 2 there. 8 times 2, 16 minus 6 is 10. Let's get one more. Plug in 3. 8 times 3, 24 minus 6 is 18. So you can see again that we're going up by 8 each time, and there is that 8. So let's use that as our common difference. Once again, we don't know what n is. We do know that 2 times a1, 2 times a sub 1 will be 2 times 2, because that is what a1 equals. And we can solve this now, because all we have is a single variable in this equation. So 2 times 2, 4, plus, let's distribute the 8. We'd have 8n minus 8. So we have n over 2 equals 4 minus 8 is negative 4 plus 8n, still equaling 4830. And then we can finish this up by distributing the n over 2 to what's inside right there. So if we distribute the n over 2, the negative 4 will cancel with that, leaving us with negative 2. So we'd have negative 2n plus, and then we have to cancel again over here. So 2 goes into itself once. It goes into 8n 4n times, and then we'd have 4n times n, which is 4n squared. And that is still equal to 4830. Now what we have is a quadratic equation. So let's subtract this to put it in standard form. And we're going to get this. We'll have 0 equals, I'm going to put the n squared term in front, and then we have minus 2n, and then we have minus 4830. Since all of these are divisible by 2, let's just divide everything by 2 to make the numbers smaller. 2n squared minus n minus 2,415. Now the question would be, does that factor? And if it does factor, it's not going to be, I don't think it's, in fact I'm pretty sure it would have to factor. It's not going to be easy to factor it though, because that's such a large number. So let's use the quadratic formula instead, which I'm writing right here. So b squared minus 4ac all over 2a. A is equal to this number 2. B is equal to, that's a negative 1 right there. And c is equal to this number, negative 2415. So yeah, this is a fairly large number, but that's probably the easiest way to do this. So we're going to have negative b. Actually, shouldn't write negative b now. I should write negative 1. Let me just fill this in. We'll leave these blank, and we'll fill them in as we go. So there's our quadratic formula. So a is equal to 2, and a is supposed to go here and here. Okay, and then we know that b equals negative 1, so b goes here, and it also goes here. Finally, we know c is equal to that big number, which is right there. And now we are hopefully going to be able to simplify this. So let's try to do that. And again, we're going to get two answers here. N is not going to be negative. We can't have a negative number of terms, so we can ignore whatever. And actually, this should not be x. This should be n right here. We can ignore whatever the negative number is. So negative negative 1 is positive 1 plus or minus. Negative 1 squared is 1. That's going to be a negative times another negative, which is a positive. And then 4 times 2 is 8. 8 times that massive number, what is that? That's 19,320, I believe. 19,320 over 4. All right, so now the only trouble right here, I believe, is that I'm not sure we're going to get a perfect square out of this. In fact, let me just double check. No, that we will get a perfect square. I'm sorry. So otherwise, that wouldn't make sense. So we'd have 1 plus or minus 19,321. Feel free to use a calculator for that. It's a large number. This turns out the square root of that number turns out to be 139. 1 minus 139, we don't want that because that's going to be a negative. So we're only going to plug in this. And again, why not a negative? Why is that a bad answer here? Because you can't, n stands for the number of terms. You can't have a negative number of terms. So 1 plus 139 is 140 over 4. And that equals 35. That's what n equals. So that means the series, let's go way back up here, the series that has, where do we begin? Here we go. The series that has this formula and that adds up to 4,830 would have 35 terms in it. So that's how we can find that.